Hey everyone, and welcome back to Wired-Tec. Today we are kicking off a brand new series, and it's a big one. We're diving deep into the history of artificial intelligence. I mean, how did we get from just dreaming about thinking machines to the world we live in right now? We're going to trace that entire journey, from science fiction to the powerful tools that are literally reshaping everything. To make sure you catch the whole story, do me a favor and hit that subscribe button so you don't miss a single part. All right, let's get into it. All right, so let's start with dreaming of thinking machines. You know, when you think about AI, you probably picture silicon chips, complex code, maybe some server farms humming away. But the story of AI, it doesn't start there, not even close. It starts way, way back, with something a lot more fundamental, our own imagination. For centuries, long before we even had the idea of a computer, we were dreaming about creating artificial minds. And I mean way back. Think about this. Jonathan Swift's Gulliver's Travels. We're talking 1726. In that book, he described this wild contraption called the engine. It was a device that could just automatically generate new ideas and even entire books. Sounds kind of familiar, right? Now, of course, it was pure fantasy, a joke even, but it planted this tiny, powerful seed of an idea. The notion that maybe, just maybe, thought itself could be automated. That little seed of an idea really took root in the cinema. I mean, look at these fictional forerunners. First, you get the film Metropolis back in 1927. Bam! One of the first, most iconic humanoid robots ever put on screen. And then, just about a decade later, you have The Wizard of Oz. And what's the Tin Man searching for? A brain. His whole journey is this heartfelt quest to have intelligence, to have feelings. These stories weren't just movies, right? They were shaping how we all thought about what an artificial being could even be. They kept the dream alive. So we're moving on to Turing's imitation game. For the longest time, the idea of a thinking machine was stuck in this loop. It was just stuff for philosophers to argue about and for storytellers to write about. But then, one person came along who was going to drag this idea, kicking and screaming, out of fiction and into the real world of science. That person was Alan Turing. And honestly, his work changed absolutely everything. See, the thing about Turing is that he was a mathematician. He was a practical guy. He got tired of the endless circular debates, but can a machine really think? Does it have a soul? He wanted to cut right through all that noise. So in 1950, he published this groundbreaking paper, Computing Machinery and Intelligence. And in it, he posed a much more useful question. Forget about philosophy for a second. How could we actually tell if a machine was thinking? He wanted a real, concrete test. And that test was what he called the imitation game. We all know it today as the Turing Test, and it is just brilliant in its simplicity. Here's how it works. You've got a human judge, okay, and they're basically texting with two other entities, but they can't see them. One of them is another person. The other one is a machine. The judge's job is to figure out which is which. And if the judge can't reliably tell the machine from the human, well, the machine passes the test. It's so clever because it just sidesteps that whole messy question of consciousness and instead focuses on one thing: performance. Can a machine act so human that we can't tell the difference? So he kicks off his paper with this incredibly simple but profound question: can machines think? And that one question, that's it. That became the central challenge, the North Star for an entire field that didn't even exist yet. See, Turing wasn't interested in just building better calculators. He was asking if we could build thinkers. And that question was the spark. It was the starting pistol that kicked off the race to create true machine intelligence. Okay, so now we're going to look at the first learning machines. Turing's question was, still pretty theoretical. It was an idea, a challenge. But it lit a fire under a whole generation of engineers who were itching to turn that theory into actual physical hardware. The challenge was now crystal clear. Could somebody, anybody, actually build a machine that didn't just follow instructions, but could actually learn? And the big idea for how to do this had actually been floating around since 1943, thanks to a paper by two guys named Warren McCulloch and Walter Pitts. Their idea was, what if we built a machine that's modeled after the human brain? So instead of having one giant central processor doing all the work, you'd have a whole network of tiny, simple, interconnected units, basically artificial neurons. And these neurons could work together to learn from experience and make decisions. We call this a neural network. And then it happened. In 1951, over at Harvard, two pioneers, Marvin Minsky and Dean Edmonds, actually did it. They built one for real. They called it the SNARC, which is a mouthful. It stands for Stochastic Neural Analog Reinforcement Calculator. But the name isn't the point. The point is, this wasn't just a paper or a theory anymore. This was a real physical machine made of wires and tubes, and it was designed to learn. And just picture this thing. This wasn't some sleek box. The SNARC was the size of a grand piano. It was this massive beast packed with 300 glowing vacuum tubes. And what was its big epic job? To pretend to be a rat learning how to get through a maze. Now that might sound a little silly, but it was actually really smart. The idea was to mimic how we thought learning worked at the time, through reinforcement. Every time the machine made a correct choice in the maze, the electrical connections for that pathway would get a little bit stronger. It was clunky for sure, but it was absolutely monumental. This was the very first time a machine was built to learn by doing. The momentum was building. The very next year, in 1952, we get another massive breakthrough. But this time, it wasn't hardware, it was software. A programmer named Christopher Strachey developed a program that could play checkers. And here's the kicker. It wasn't just programmed with the rules and a bunch of if-then statements. No, this program actually learned. It would play games, analyze its mistakes, and adjust its strategy. It literally got better over time all by itself. This was one of the very first, most powerful examples of what we now call machine learning. So, okay, let's step back a second and think about giving this whole idea a name. By the mid-1950s, you've got all these brilliant minds working on these incredible but separate projects. You've got Turing's big theoretical question. You have Minsky building brain-like hardware. You have Strachey writing self-improving software. They were all kind of chasing the same thing, but they didn't have a name for it. It was just this collection of cool experiments with no unifying identity. And just think about the timeline here. The pace was just wild. In 1950, Alan Turing asks his big question. A year later, in 51, the SNARC neural network gets built. The very next year, 52, we get Strachey's learning checkers program. Boom, boom, boom. This wasn't a slow burn. It was an explosion. By 1955, it was obvious to everyone involved that this wasn't just a handful of quirky, isolated projects anymore. A whole new field of science was being born right before their eyes, and it desperately, desperately needed a name. And that crucial moment came in 1955 in a proposal for a summer workshop at Dartmouth College. This thing was written by a who's who of geniuses. We're talking John McCarthy, Marvin Minsky, the guy who built the SNARC, Nathaniel Rochester from IBM, and the legendary Claude Shannon from Bell Labs. Basically, the Avengers of early computing. And their plan was to get all the top minds together in one room to officially kick off this new scientific field. And right there in that proposal, they coined the term. They gave it the name that would define the next 70+ years of innovation, artificial intelligence. And they laid out the mission statement too. It was all about making machines that could do things that, up until then, were exclusively human, like using language, forming abstract concepts, and solving complex problems. The name was perfect. It stuck. And suddenly, this scattered collection of projects had a name, an identity, and a seriously ambitious goal. So Turing proved that machines could do more than just calculate. These early pioneers built machines that could learn. And now, the field finally had a name. But a name and a proposal are one thing. An actual scientific field is another. The real birth, the moment this all became official, happened at that workshop. So that leads us to our cliffhanger for this week. Turing proved machines could calculate, but they needed a name and a direction. What happened in the summer of 1956 that officially gave birth to this field? We're going to answer that in part 2, so make sure you're subscribed to Wired-Tec so you don't miss it. Thanks for watching.